This is a video walkthrough for practice 7C. In 1, we're asked what's the most efficient way to solve each of the following quadratic equations. And in A, we have a coefficient of x squared, which is equal to 1. And the coefficient of x is an even number, so therefore complete the square is the most efficient method for solving. In B, we have a trinomial that is factorable, and I know that the trinomial is factorable because A times C is 2 times negative 6. Factors that add to B of negative 12 are negative 4 and positive 3. And so factoring is going to be our most efficient way to solve that equation. In C, we have an equation in the form something squared equals a number. And so we're going to solve by taking the square root of both sides. In D, we have something that is A is equal to 1 and B is not even. It's not factorable, and it's not in the form something squared equals a number. So for those reasons, we exhausted all other possibilities, so we're going to use the quadratic formula to solve. In 2, we can do a u substitution, where u is equal to the square root of x, and if we square both sides of that equation, u squared will be equal to x. So replacing the x with u squared and the square root of x with u, we get u squared minus 2u equals 8. Let's subtract 8 from both sides and factor. The factors are u minus 4 and u plus 2. So either u minus 4 is equal to 0 or u plus 2 is equal to 0. So u is 4 or u is equal to negative 2. Now let's back substitute. So either the square root of x is equal to 4 or the square root of x is equal to negative 2. On the left, square root of x is equal to 4. We can square both sides and get a solution of x equals 16. On the right, the square root of x is equal to negative 2 is not possible. A square root never produces a negative number, so there is no solution there. What this means is we have just one solution to this equation, x equals 16. In 3, we have p to the 4th minus 16 is equal to 0. We can let u equal p squared, and u squared would be equal to p to the 4th. So if we replace our p to the 4th with u squared, then we get u squared minus 16 is equal to 0. We can solve this one easily with a square root by moving the 16 to the other side, and then solving, and u is equal to plus or minus 4. So what that means is u, which can be replaced with p squared, is equal to positive 4, or u, which is equal to p squared, is equal to negative 4. Now we can take a square root again to solve for p. If p squared is equal to 4, then p is equal to the positive or negative square root of 4, which is positive or negative 2. And if p squared is equal to negative 4, then p is equal to the positive or negative square root of negative 4, which is positive or negative 2i. So see, we have 4 solutions for this equation, 2 real and 2 non-real. In 4, we have 2 exponents, one which is twice the other. So if we let u equal x to the 1/3, then u squared will be equal to x to the 1/3, the quantity squared, which is x to the 2/3. Making that substitution, we have u squared minus 3u equals 10. Moving the 10 to the left side of the equation so that we have 0 on one side, we can factor u minus 5 times u plus 2. And so u minus 5 is equal to 0, or u plus 2 is equal to 0, which gives us solutions of u equal 5 or u equal -2. Now let's not forget to back substitute. U is x to the 1/3. So if we replace u with x to the 1/3, then we need to solve each of these equations. Remember that x to the 1/3 means the cube root of x, so we can cube both sides, and we get x is equal to 5 cubed, or 125. Cubing both sides for the equation on the right, we get x is equal to -8. Neither are extraneous solutions because cube root equations do not produce extraneous solutions. In 5, we can let u equal 5n plus 1. So 5n plus 1 squared will become u squared. 5n plus 1 becomes u. And now we have u squared plus 2u minus 3 is equal to 0. This is an equation where factoring is a valid method. U plus 3 times u minus 1. So u plus 3 is equal to 0, or u minus 1 is equal to 0. This gives us u equals -3, or u equals 1. Let's not forget to replace u with 5n plus 1. So 5n plus 1 is equal to -3, or 5n plus 1 is equal to 1. On our left equation, we can subtract 1 and divide by 5. And in our equation on the right, we can subtract 1 and divide by 5. We get two solutions, -4/5 and 0. In 6, we can let u equal r squared, which means u squared is r squared squared, which is r to the 4th. Making that substitution, u squared plus 36 equals 13u. Subtract 13u from both sides and factor. U minus 9 times u minus 4 is equal to 0. So u minus 9 is equal to 0, or u minus 4 is equal to 0, which gives us u equal 9, or u is equal to +4. Let's make a substitution, or a back substitution. U was originally r squared, so r squared is equal to 9, or r squared is equal to 4, which is going to give us r equals ±3, or r equals ±2. So 4 solutions total. In 7, a u substitution is not really necessary. We can just factor, and we have 4 terms that cannot be combined, so let's factor by grouping. I believe in our first 2 terms here we can factor out a y, and we get y squared plus 9. And then in our second pair of terms we can factor out -1, and we get y squared plus 9 as the remaining factor. So finishing the factor by grouping, this is y squared plus 9 times y minus 1. And so either y squared plus 9 is equal to 0, or y minus 1 is equal to 0. If y squared plus 9 is equal to 0, then y squared is equal to -9. Taking a square root of both sides, y is equal to the positive or negative square root of -9, which is positive or negative 3i. If we add 1 to both sides of the other equation, we have y is equal to 1. So we have a total of 3 solutions, 2 imaginary and 1 real. In 8, we have a trinomial with 2 exponents on x, one of which is twice the other. So we can let u equal x to the -1, and so u squared is x to the -1 squared, or x to the -2. Making that substitution, u squared minus u minus 6 is equal to 0. and factoring u minus 3 times u plus 2 is equal to 0. So u minus 3 is equal to 0, or u plus 2 is equal to 0. And that gives us solutions of u equal 3 or u equal to negative 2. Let's make our back substitution. U can be replaced with x to the negative 1. So either x to the negative 1 is equal to 3 or x to the negative 1 is negative 2. This is a good situation where we can take and raise each side to the negative 1 power, because when we raise a power to a power, we multiply exponents, and when we multiply negative 1 and positive 1, we get 1. So the left side produces x to the 1, and the right side is 3 to the negative 1, which simplifies to 1/3. And our second solution is the reciprocal of negative 2, which is negative 1/2. In 9, our equation is not quite in quadratic form, so we're going to multiply both sides by n minus 2. So let's multiply each term by n minus 2. When we multiply the fraction times n minus 2, the n minus 2's cancel or divide out, and 0 times n minus 2 is n minus 2. Now we have n squared minus 2n plus 5 is equal to 0. Let's analyze the method that we need to use for solving this equation. This is a quadratic equation. No u substitution is necessary, but our a value is 1 and our b value is an even number. Even though this is not factorable, complete the square is an easy method. So n squared minus 2n plus blank is equal to, move the constant to the other side, negative 5 plus blank. Let's draw our picture for complete the square. N squared minus 1n minus 1n, and that means our factors are n minus 1 and n minus 1, and we complete the square with a positive 1. So n minus 1 squared is equal to negative 5 plus 1, which is negative 4. So we can solve by taking a square root. N minus 1 must be equal to the positive or negative square root of negative 4, which is positive or negative 2i. Adding 1, we get two solutions, 1 plus 2i and 1 minus 2i. In 10, this is a 4th degree polynomial, and so you may decide to do this with a u substitution. You may do it without a u substitution. You can probably factor it as is. If you decide to factor it as is without a u substitution, bear in mind that the two factors must start with a squared, because a squared times a squared is a to the 4th. And the lasts in each of the parentheses must multiply to positive 6 and add to negative 5. So negative 3 and negative 2. And let's just check our middle terms. Negative 2a squared, negative 3a squared add up to negative 5a squared. So that factoring works. So a squared minus 3 times a squared minus 2 is equal to 0, which